and welcome to the fourth video of the Sustainable Aquaculture Program at Home Edition. In the last video, we learned that animals need three basic things to survive: food, water, and shelter. And we focused on food last week. We looked at a few examples of some animals and came to the conclusion that they do not all eat the same foods, or even eat the same foods during different stages of their life. But it isn't just enough to feed these animals. You have to have the correct tank or enclosure for the animal you are trying to raise, and you have to have healthy water for them to live in. So those are the two things that we're going to focus on today. If you've ever been to an aquarium, you probably spent a lot of time looking at the animals. But have you ever spent some time looking at the tanks that they're in? Maybe not, and it might not seem like a big deal, but the tank sizes and shapes are determined based on the species and what life stage it's at. Most of you are probably familiar with the standard rectangular fish tank. That is used for most animals at their adult stage of their life. At this stage, they really don't need a special tank setup. However, when these animals were larvae or plankton, they were probably raised in something called a larval rearing tank. A larval rearing tank is cylindrical in shape, and it's designed so that the drain is in the center, and then the flow of water runs through the tank along the edges. This allows the larva to flow through the tank without getting sucked down the drain. Larval rearing tanks are actually based off of a different kind of tank called a chrysal. Chrysals are also circular, and they're mainly used for raising jellyfish. This tank creates a circular flow of water that carries the jellyfish round and round so they don't sink to the bottom of the tank. Larval rearing tanks are one of the most commonly used tanks in aquaculture farms. But they might also use some enclosures that sit out in an open body of water, and we're going to look at those in the next video. Now that we've decided which kind of tank is best for aquaculture, we have to fill it with healthy water. If any of you have a fish tank at home, you know that you have to test the water quality of the water inside of your tank. Well, the same is true for aquaculture and aquariums, except usually on a much larger scale. Your water quality test kit at home might look something like this, where you have test strips or a liquid that you have to test the water inside of your tank with. There are many different parameters that aquaculture scientists have to test, and these are some of them. One of the most important things to measure, especially if you have a saltwater tank, is the salinity, or how salty your water is. What you raise will determine how salty the water in your tank should be. So if you're raising trout or catfish, you will need fresh water, which has a salinity of nearly 0 parts per thousand. If you're raising shrimp or salmon, then you will need salt water, which has a salinity of about 35 parts per thousand. Maintaining the correct salinity level is really essential for the overall health of your animals. One way that you can measure the salinity in your water is by using a tool called a refractometer. This tool measures the amount of light that has been refracted by the salt that's in the water. So an example of refraction is what happens when you place a straw inside of a cup of water. As soon as the straw hits the water, it looks to be bent. This is due to the refraction of the image inside of the water. Salinity is measured in the units parts per thousand, which is used to measure something that is dissolved inside of a liquid. So like I said, salt water is 35 parts per thousand. So that means that there are 35 grams of salt per 1,000 grams of seawater. Another factor that's important to test is the ammonia, nitrite, and nitrate levels. Ammonia comes from animal waste and food that's left over in the tank. As ammonia breaks down, it gets converted into nitrite and then to nitrate by nitrifying bacteria. Sound familiar? Well, that's because it's the nitrogen cycle. The ammonia and nitrite levels should not get too high in the tank because they can actually be toxic to your animals. And then the last test that we're going to talk about is pH. pH is the measurement of how acidic or basic something is. It runs on a scale from 1 to 14, closer to 1 being more acidic, like lemon juice, closer to 14 being more basic, like baking soda, and 7 being neutral, like drinking water. The average pH of ocean water is around 8, so it is slightly basic. Today I'm going to demonstrate a test that you can replicate at home that measures the pH of different household items. This is the red cabbage pH indicator test. For this experiment, you will need hot water, a red cabbage, a blender, household bleach, baking soda, pineapple juice or tomato juice or coffee will work as well, lemon juice, and a few containers. The first step will be to prepare your cabbage juice. Make sure you have your parents' help for this part. So the first step is to cut up 2 cups of cabbage. Now go ahead and place that into your blender. Then you're going to take your hot water and pour it into the blender just until it covers up the cabbage. Put the top on, and then you're going to blend it until almost all of the big chunks are gone. Now that your cabbage has been blended, pour out the contents from the blender into another cup, passing it either through a coffee filter or a strainer with really fine holes. This will catch all of the larger chunks that are still left over. Then pour out the cabbage juice into 2 containers. Make sure to leave enough room at the top of the container for other liquids to be added. Cabbage juice has a neutral pH of 7 and will change color depending on the pH of the liquid that is added to it. Acids, such as lemon juice, will turn the cabbage juice a very bright red color. This indicates that it is a strong acid with a pH of about 2. Pineapple juice, when added to it, turns more of a magenta color. This indicates that pineapple juice is a weaker acid than lemon juice with a pH of around 3 or 4. Now, fill up 2 more containers with cabbage juice. On the opposite side of 7, you have your bases. Bases such as bleach will turn the cabbage juice a greenish yellow color. This indicates that it is a very strong base with a pH of about 12. Baking soda, which you should dissolve in warm water, when you add it to the liquid, it turns a blue color. This indicates that it is a much weaker base with a pH of around 8. So let's say you're raising freshwater trout and saltwater shrimp. Which of these pH solutions would most closely match the pH of the water that you should put them in? Would it be the acid, the neutral liquid, the weak base, or the strong base? Well, for freshwater trout, if you chose the neutral liquid with a pH of 7, then you would be correct. This neutral liquid best matches the pH of freshwater. However, the pH of freshwater can vary a bit. For the saltwater shrimp, if you chose the weak base, you would be correct, because this weak base has a pH of about 8, which most closely matches the pH of ocean water. pH, salinity, and ammonia are very important water quality tests that scientists have to do. If any of these tests are not what they should be, unfortunately the animal being raised could die. So that's why water quality testing is very important for the overall success of an aquaculture farm. So now that aquaculture scientists know what animal they're going to raise, what kind of tank they're going to need, how to maintain the water, and how to feed them, they can begin raising their animal. That's a lot to know before starting a farm, but it's really important work. Although we're not raising animals in this class, make sure you watch the next episode if you want to test your knowledge in creating your own aquaculture enclosure. Thanks for joining us, and see you next time.